Hi everyone, and welcome to today's software webinar on rural or county road design using RoadEng Civil Engineer. For those of you here in the live version of the webinar, please ask questions and engage with us through the Q&A section of the GoToWebinar panel. We'll address all your questions at the end of the webinar. Okay, so let's get started by reviewing a typical workflow for designing a rural road. We start by importing our topo. The terrain module is used to import and verify survey data. Possible data sources include total station, LiDAR, or GIS maps, or file types that you might be familiar, such as shape, DWG, DGN files, and etc. Still in the terrain module, break lines and other linear features are identified and connected. A tin, triangular irregular network surface representing original ground is created. The resulting line work and tin surface are saved in a .trx file. The rest of the steps are completed in the location module, our specialized module built for corridor design. Here, a new design is created and is based off our OG surface, also known as the .trx file from step 2. The road cross-section is created or adjusted using the template editor. Then the horizontal alignment is created or adjusted. A vertical alignment is created or adjusted. And in this process, vertical optimization through our an add-on called Software Optimal can also be used in this step. Steps 4 to 6 are then repeated until the designer is satisfied with the results. In addition to our plan, profile, and cross-section views, various reporting tools provide the designer with feedback. This includes volumes, the mass haul diagram, and cost reporting. Finally, construction documentation is prepared using the multiply window. This documentation is printed directly or exported to CAD, and LandXML or ASCII files can also be saved for construction staking. Today's webinar is going to focus on steps 3 to 8, and we're going to start in the location module with our tin surface already created. So with that, let's check out this workflow in a live example, and I'm now ready to pass it over to our senior engineer, Craig Spears.
Thanks, Andy. Good morning, good afternoon, everyone. So as Andy mentioned, we are at a starting point here where we actually have a terrain model that's being created. This is our terrain program. And just to illustrate what we've actually got a triangular mesh which represents the original ground surface. And in this case, it's been created from total station data, and it's also gone through a process where break lines have been set up, and that model was built and it's now ready to go. Also, there's features identified in here. I've got an existing alignment that was surveyed, and that happens to be currently selected. This particular project, I'll give you a little peek at it. It is actually it's a rural county road, and background, I'm going to turn on the display so we can see some imagery in the back just to give you an idea. Quite rural. We're actually going to realign a road in a obviously very rural situation, and very flat as well, not like a steep west coast rocky situation. Anyway, let's just carry on. I'll turn this off, minimize this window, and I'm going to switch over to our corridor or location design, as we call it, and begin doing the realignment process. So the first thing I'm going to do is to create a new alignment, new corridor, new file, and I pick my topo file or original ground file. There it is there. Open that. Now it's going to ask me for an initial alignment. I could get that from lots of sources. In this case, I'm going to choose that selected feature centerline 13 as my initial alignment. And it's asking me for a cross section. I'm going to just take the default there and go ahead. And we're now in what's called the location design program. So very briefly, I know there's quite a few people who've never seen RoadEng. RoadEng is a three-dimensional modeling tool that's made for corridors, and it's very interactive. Any change in any window that I make will be reflected in other windows, so I can make a change somewhere out here in my plan window, and I'll see the result of that change in the profile window. I think you'll see this in action when we get a bit further into this demonstration. I have other windows available. I've got a data window which contains reporting information, and that similarly is live. It's all connected. And I also have a 3D window here. You can review your alignment in 3D in real time as you design it. So everything's connected. It's all built together from the ground, all related to each other. So first thing I want to talk a little bit about is cross sections. You've got the basic ingredients of a road design. You've got a plan view, you've got a profile or horizontal alignment, vertical alignment, and you've got the cross section. And to get at and change the cross sections, I go into what we call the template editor. And this is an area of our program where you can play around like a sandbox. You can play around with a cross section. So here I've got a template that's my default. It's called rural, and you can see it's got ditches and it's got some material layers on it. There's a lot of possibilities here. The template itself is a smart object. So if I pull this up, you see the ditches went away when I get into a fill situation, and they come back when I get into a cut situation. So the template itself has a set of rules and can be somewhat complicated. Thankfully, we have an e-library that includes a lot of different components that you can pick and choose from to put together your cross section. Just to give you an idea of some of the things that are available. Here, roadway components, different situations, walls and barriers. There's all sorts of different components that you can use to build your cross section for your situation. So now I've got this default template set. Let's just have a look at some of the components that are in this template. The first one is called Rural 1, which is a roadway. You see when I selected it, becomes magenta there. If I click on the properties, I have all the different parameters that are associated with that. So ACP thick is the thickness of pavement. Yes, this thickness of pavement. There's the lane width, and so on. You can change any of these parameters and it would be reflected. So here, let's make this 12, and you can see the road is now wider. There's a shoulder variable here, shoulder gravel width. There might be a paved shoulder as well. So at the component level, all these parameters can be changed. And you can mix and match components. So I can bring in components from the e-library, paste them in here to build my cross section. Yeah, this part of the software might be it's very flexible, might be the hardest piece for many users. We help people with this, and yeah, there's quite a few different situations that we can handle. One other thing I just mentioned while I'm in here is that this particular cross section, you can see, has different materials. So if I hover in this area, and I can actually shade that, this is a material, it's called fill, OB fill. and that is fill underneath my subgrade line. I can also track material that's in here. That might be some sort of granular material that's in the road base. So these materials are tracked, and when we get into actually doing the design, all the quantities and so on for these materials will be tracked. And again, the template editor where I am now is just, it's like a sandbox. You can move the template around just to see how it behaves. I'm just clicking and dragging. You can see like that. We can look at another template here. It's got flatter slope angles, and I can see how that behaves. So in this particular template, I can change my cut slope or my fill slope. I can change that from 4:1 to 3:1, and so on. I'm gonna keep going here. Templates could take up a full webinar just talking about templates. Anyway, I've got my default template set, and here my horizontal alignment is my original survey, and the profile is sitting right on the ground of the original survey. So what I'm going to do is I'm going to create a horizontal alignment, a new horizontal alignment, which will be realigned. It'll be a little faster than the original was. So I'm going to call this Route 61, and I'm going to just go ahead and create that, and I'm going to start at just a coordinate point, and I'll apply the default template to this. So there's my starting point. You notice the other alignment went into the background. It's there. I can switch back and forth, but I'm going to come and bring this starting point down here, left click, come up here with my mouse, left click somewhere about here. I'm just putting in the IPs. I'm going to come back and put in curves in a second. Over here, left click somewhere about there. I'm obviously doing this very quickly, so don't judge me on my mouse clicking. There we go there. So just having a look at that. Yeah, it's about right. Okay. Excuse me. Okay, so next thing I'm going to do with this is to add some horizontal curves. I'll come up here into my horizontal curve panel, and I've got a tool that will give me some curves very quickly, auto-generate curves, and I'm going to tell it I want, this project, by the way, is in feet. We work in meters or feet. This particular project is in feet, so I want minimum tangent lengths of 50 between the curves that I generate. And now you can see, if you look there, you can see those are the IPs that I put in, and I've got curves that are a little gentler than the original alignment. Now I can go through, let me just close this. I can go through curve by curve. Let's go back to this one, and it's given me a radius. It's calculated a radius of 670. Let's up that. Let's make it a little faster. Apply that. And now I have a longer curve in there. I'll go to the next one using in the curve panel here. So I'm back to this one. It's got another curve about 670. Let's make that the same, 850. Apply. And you can see what's going on. I have now a new alignment that's faster and probably safer. Anyway, yeah. So there's the horizontal alignment, and let's just have a look at some of the cross sections. They're still just sitting on the original ground, but if you look at those sections, we'll start here and we can just move through the sections as we come into the, start a bit closer. As we come into the curve, you see the super elevation on the template is starting to apply. And we get into full super in the middle of the curve somewhere. And that super elevation is controlled normally through a curve table like AASHTO, and I can look at that table. So I've got the wrong panel here. This panel here, there's a table that I can get at and look at that's got AASHTO values that will determine the rate of super elevation. Okay, so that is very, very quickly the horizontal line. By the way, I can change anything at any time here. I can come back and I can go back and move that IP point. I can do you know, I can actually add an IP point in here in the middle somewhere if I wanted. So it's very dynamic. So now let's look at the profile window. Let's just reconfigure a little bit here. By the way, as Andy mentioned, if you have questions as we go, type them in. We're happy to try and answer them as we go. So I'm going to very quickly create a vertical alignment. So come here. There's a very quick set of vertical IP points. And, you know, again, I can move these points around, left click, move, and so on. So with this, I'm going to go into our vertical curve panel. Let me get rid of this. Vertical curves, lock this down. I'm going to go to each curve and I'm going to apply a curve at that vertical IP. And let's go with a K value of 250. Again, this is in feet. So there's your vertical curve. There's the beginning of the vertical curve, the end of the vertical curve. Let's move to the next IP. Same thing, I'm going to apply a parabola, K value 250. There, now we've got a smooth alignment. It's very basic. And as I mentioned, you can change anything at any time. So now begins the fun process of trying to wiggle the alignment around to get it just the way you want. So that's what I'm going to try and do now. Let me just work on the profile window. And I'm going to put at the bottom of the profile window what's called a mass Hall graph. Pop that in there. And the alignment I've got now, I've got too much material. You can see it's going up, it's going up, it's going up. So I'm cutting too much. I need to get rid of some material. So one way of doing that is obviously just move the alignment up a bit. Click on here, move it up. And now we've got more of a balanced situation. You've got cutting going on from here to about station 1000. And then we get more filling, and you can see the mass hull is coming down there. And material, this is showing you the material movement. So in this zone here, this would be considered free haul, very short distance movement, whereas this movement here would probably be an overhaul or end haul type of movement. So you can play around with this. We've still got too much material at the end here. I can see I've got about 7,500 cubic yards of material, so I could pick this up a little bit. Let's see. So this, like I say, is the fun part of it. Now I've got not enough material, so I've got to cut a little bit more. Maybe I could cut here a bit more, and so on. Now if you had, it looks like I'm pretty close there within tolerance. You can fiddle it until you get it perfectly balanced, or you can import material into your design to get that design quantity. Yeah, so what else can we do? I'm not going to go into it today, but we actually have an optimization technology that's available. And basically with a button push, I can optimize this alignment so that the material cutting and filling and movement costs are minimized. It's a patented technology. Again, I think it deserves more than this introductory menu or webinar. Let me just put my panel over here. There we go. Now, with this alignment, that includes the horizontal, vertical, and the cross section, I actually have a cost. So let's just recost this. I'm going to recost it, which isn't set automatically. It's going to recalculate the cost. And what it's telling me is that this alignment is going to cost $134,000. That's based on costs that are set up in your material types. So if you look at costs here, you have an excavation cost of $8 per cubic yard. You have an embankment cost of $3. And then you have haulage costs, which depend on the category of movement. And this recosting tool figures out how much it's going to cost to cut, how much it's going to cost to fill, and how much it's going to cost to haul if there was a big haul movement in your design. So this design, it is flat ground, fairly inexpensive. Probably the surfacing materials would be certainly more cost than the earthwork. Okay, so let's suppose I have a perfect design here. I've fiddled it. It's just the way I want it. How can I check it? Well, one obvious way of checking it is to just scroll through the sections. And if you find there's a section that you don't want or is inappropriate, you can change it. You can override some of the parameters in it, or you can realign the whole corridor. But anyway, you can check very quickly. Another good way to check is using the 3D visualization. I can come in here, just have a look at what's going on. There's my original alignment, and here is my new alignment. Looks pretty good. I don't see any bad sections or anything like that. Now, the other thing I didn't mention is that as you're designing in the plan window here, you can see the limits of your what we call slope stakes. So if I turn the background off, so we can just see the two alignments. You see this line here, the green line, is your edge of excavation. Let's get in here to a section somewhere in here. So this line here, see in my cross section, is the toe of fill. And similarly on the other side, toe of fill. So if you moved into a big cut or a big fill situation, you'd see these lines take off, and it would be an indicator. The blue lines are the edge of road. They're those points on the subgrade. You could also report other points. This one here looks like it might be edge of pavement or shoulder, and so on. So you get that visual feedback as you're designing. Okay, so we've done a design, we've checked it pretty quickly, and now we want to produce some construction documentation. So there's a couple of ways you can go here. If you're a heavy CAD user, you can simply export any one of these windows, save as. You can export them to DWG. And of course, you get to choose which of the windows you want, and you'll get those windows appearing in a DWG file, and you can either give this to your CAD person or whatever. Yeah, so you have that option. You also have an option right in the software to build an output sheet. Well, and by the way, any of these windows will print. Print preview, I can print there's a preview of the plan window. But you also have the option of creating an output sheet, and that's done with what we call multiplot. Here's a window, and the way this works is you can set up various different windows on the sheet, First of all, you would have a paper size that you're working with, page size. Say you want to work with 11 by 17. It was the default. There's a plan window. And I can add another window, which might be a profile window, and so on. I can organize them on the sheet, and I can also add other views, rectangles, images, scale bars, things like that, and I can create my own output sheet, and it will paginate it for you. So you can basically create a custom sheet. You can also retrieve one that you've previously created. I'm just going to delete these for a sec, and I'm going to open a book layout, place the current layout. I got one called construction doc. Let's just open that up. You can see there's one that's obviously been prepared before, but it's got, you know, information the way you like it. And in this case, you can see there's a title block, and then I've got different pages, and it's going to auto scroll through your design page by page, showing you a plan and profile. And down here I've got cross-section sheets. And all this is printable or exportable to a printer or to AutoCAD. So you have this ability to create an output sheet. The other thing you're probably going to want to do is to create construction staking notes, and you can do that in a couple of ways. Most commonly now is to save the file as XML, file save as, and I'll choose XML here. There we go, XML, and this will create a surface file which can be read by machine grading software, and you can give that to your contractor. It will also import into other design software as a surface, so you can use it in other design software as a surface. So there's some options there. Essentially, it will create a tin surface. The other way I can get information out of this is to look at my data window. And here I've got columns set up. I've got my stationing, and I've got cut, fill, mass haul volume, and then surfacing volumes. And I can just copy this to the clipboard. I want to give the construction people some information, and I can paste it into Excel. Paste, and there we go. Of course, everything's configurable. There's quite a few options in here. I can control the columns. Similarly, all the windows are configurable. There's a lot, but at the same time, you'll notice that there is not millions of options here. It's very lightweight software. I think that basically covers everything I want to cover. Andy, do you have any questions that need answering?
Hi again, Craig. Let's see. Okay, so we have a couple of questions that came in, Craig. Let's get started with this one. The first question is, where do you set the shrinkage factors? Do they apply?
Okay.
Do they apply to the mass haul diagram?
Absolutely, yes. There's lots of things I did not cover, but that's a good one. So in here, in the ground types, this is the material that's under your in the natural original ground. These materials. In there are two factors: expansion, cut factor, and a fill factor, which essentially are expansion and compaction. And yeah, you would set those. And that would be included in the mass haul, and it would change the volumes. Let me just illustrate that if you like. Here's a data window. Let me put some totals on it. design totals, come down to the bottom here. There is your expanded and compacted volumes. I'll just change that so that my material has a, let's go with 1.2. Watch, those numbers will change after it recalculates. And the mass haul, of course, will be affected as well. So you saw that number change. So yeah, that is totally available to do.
Thank you, Craig. And there's also, I thought this was also a good question. How do you set up both cut and fill templates for various sections of the road?
Okay, yeah, that's a good question. Yeah, so I didn't really go through that, but yeah, let's suppose here I've got, starting down here, I've got this template. We'll have a look at that. We already looked at that, got the default rural. Suppose I get out to somewhere here and I want to change templates. So I could assign another template. I do that, sorry, here, assign by range. Templates, I can choose to assign another template, say RP2 from station 1940 to, oh, let's go with 2100. So now I've got a completely different template there, which may cause sort of a discontinuity when I calculate it, but I can put a taper in between the two templates. So there you can see what's going on. Right starting there, I've got an abrupt change in template out to here. So that template, the cross-section is completely different. And if I wanted to transition from one template to another, I could do that as well by assigning what's called a transition template. So a taper template. So I might go 1940 to 1950. Oh, no, wait a sec. Sorry, get confused. 1930 to 1940. And now I've got rural, taper, and then this other template. So I should, I'll get a transition between those two. You can see how that, a 10-foot transition. There's quite a few other things you can do. You can control things like individual parameters in a template. So you could, I'll go in here, assign by range. I can actually override different parameters that are in the template at a particular station to cause a widening or maybe a deeper ditch or something like that. So you can control the cross-section by overriding parameters. You can also create other alignments and control the alignment like a ditch profile from another alignment. So there's quite a bit there that I haven't talked about. I hope
Thanks,
that
Craig.
answers the question.
On a similar note, I guess we could do one more question. Can this software do a widening project?
Widening project, that's absolutely yes. For a widening, maybe we want to switch back to the original alignment. I've got this and look at that original. And I could probably put a template on here that represents a widening. Let's go into our overlays and widenings folder. And I've got one here that is a widening. So I would copy this component, put that, I can actually make a new template, or yeah, what's best? I'll just put it in here, default. So I'll paste that in, left, and I'll delete that. And of course I could only widen on one side if I wanted. I just delete some of these components on the right side. So I'm just getting a widening happening on the right side. And this properties of this, let's make this a bit wider, widening width. That's the additional width of widening. Let's go with 10 feet, whatever. There's a widening. Oh, let's go even bigger. How are we doing for time? Okay. There we go. It's a bit more visible. And then I just press OK, and I now have widening sections on one side of the road. So yeah, with a ditch formed and so on. So the short answer is yes, you can do widening. You can do milling and overlaying type of projects. That answers your question.
Two great similar questions for you, Craig. How do you account for intersections and driveways? And the latter part is how would you add a secondary road that were a part of the original design?
Right, right. I don't know if I can answer that question very quickly, but I can show you the concept, I think. First of all, this particular design has some other roads in it. So I'm just going to turn on the background here. One way of doing it, and there is a couple, for example, you've got kind of a side road here, private road or something going on, and you want to make sure you've got the earthwork quantities right through this corner. So I could create another alignment, new alignment, to call this private road. And I'm going to go with just starting. I'm not going to apply a template to this. I'm just going to create a controlling feature. And now I'll quickly create an alignment in there. I'll come there somewhere, and then there, here. So I'll just model it back, because when I calculate my cross sections, they're going to be perpendicular to the alignment. So I'm only going to be really modeling it in a cross-sectional way. If I wanted something more three-dimensional, I would have to go back to the terrain to get a. So there's a driveway coming off. Again, I would probably put some curves on this. Close this for a sec, close this back. Okay, and I'm going to apply a curve. Why isn't it? I tell you what, it's going to take a little bit of fiddling around. Basically, I'd create a curved alignment in here, and I was actually going to do this as part of the demo. I'm going to just open up a file that has this in it to illustrate what I would do. So I'm going to open a file that I previously did. Do I need to save this? Oh, I might save it first. Let's call this Route 61. And yes, I'll just open that quickly and show you what would take me probably 5 or 10 minutes of fiddling around awkwardly. So here I've got an entrance component set in here, and I've designed that with curves, and it's going back into the driveway. It doesn't have a profile. All I care about is the extent of it in plan. And then on my Route 61, I actually tied my template so that it will attach to that. So if we look at a cross section in here, you can see, if you look at the section, you see I've got a surface that's extending out at a slope that I define and grading back into the driveway. So A better way to see that's probably in 3D. We could just look at there. There it is there. So it's pulled the template out to follow that driveway entrance or private road. That's one way. And it's giving me cross sections which show that. Another approach to this sort of thing is to actually construct this first alignment, save it and merge it back into the original ground, and then design this alignment based on that new ground situation. Yeah, I have not fully answered that question because it probably require a whole seminar just to show you some of the tools that are available for doing that kind of thing.
Okay, well, let's just tackle 2 more questions, and I would also like to thank the audience for staying with us and being engaged. And Craig, the first question, the next question is, in RoadEng, can you do a 3-dimensional drive-through from the driver's perspective?
Oh, hey, that's a good question. I thought I was going to do that. Okay, yeah, absolutely you can. So let me go back to my Route 61 design so we can see how bad a job I did. And we'll switch alignments back to the route itself. There we go. And I go to my 3D window. And there's my design. I might want to include the original ground surface so I can see where cutting and filling is going on. So I'll include that. And I'll give it some different color and I'll make it transparent so I can see through it. Okay, and then I right click and go drive through flyby. And now I'm seeing my road surface with the cut and fill on it. And there we go. I think it actually looks better if you don't put the original ground in. And of course you could cut a hole of the original ground and do something even fancier, but it's just not. Display triangles. I could do that. There's the original ground. Drive through. Yeah, so you get a quick visualization. Most of the 3D capability in our software is really oriented towards engineering, finding problems. It's not a super high-end visualization tool. So yes, hope that answers that question.
Thank you, Craig. You're doing an awesome job. The final question is, can you add culverts in RoadEng?
Short answer is yes. Adding a culvert, let's have a look at this design. Let's have a look at the profile. Suppose we want to put in a culvert somewhere down here. That makes sense. Oh, I trashed my, let me refix this template. I've only got a widening. Oh boy. Let me switch to another template. That'll fix that. Sign by range. Let's go with RP2, the whole road. Okay. Brand new cross section. Okay, so let's put in a culvert here at this station. So we have a special tool that's called the culvert editor to do that. Culvert editor. And now I'm going to add a culvert at my station 3240, and there it is. It's set a default length of 5. I can actually set it to look at the slope stake positions and the cross section and try to figure out what the culvert would look like. So there's a culvert, and I can make it a bigger culvert, a 6-inch culvert. Let's say it's a 24-inch culvert. circular pipe, or it could be a pipe arch or rectangular box. There's some other options here as well. There's my culvert, and now looking in plan view, I should see at my station, there you go, you can see the culvert that I've created. I could also skew the culvert so it follows the actual, there we go. So there's a skewed culvert at that station. So there's a few other things. You actually can model culverts as separate alignments. You can also put in bridges. Basically a bridge is a section where there's no cut or fill. I hope that answers that question.
Yes, it certainly has. And since we've gone over 15 minutes outside of our scheduled time, I'd like to thank everyone for joining today's webinar. And I guess and get back to the rest of the pending questions that have not been answered.
Okay. We're going to respond to those by email, I guess.
Yes, certainly. That's what I meant.
Okay. Well, I think we're good to go.
Yep. I guess we'll leave it at that. And thanks again, everyone, and have a great day. Bye now.
See you later, everyone.
Thanks for watching another Softree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.